into substrings with values at most k. So we are giving a string as consisting of digits from 1 to 9 and an integer k. And a partition of the string s is called good if each digit of s is part of exactly one string. Yeah. So we just need to split it into different parts, and each of them should at least have one character. So this is just the meaning. So s consists of any digit numbers, and the value of each substring is less than or equal to k. So the value is, so for example, 1, 2, 3, the value is 123. So for string 1, the value is 1. Yeah, we just need to return the minimum number of substrings in a good partition of S. If no good partition of S exists, we're gonna return a -1. Yeah, so the idea is that we're gonna return the minimum number of substrings in a good partition of S. It's not the maximum number of substrings, it is the minimum number. So if we think about this minimum number, or the maximum number, maybe we're gonna think about it as a greedy problem. So normally for all the algorithm problems, first of all, we're gonna think about maybe dynamic programming. If it is too hard, maybe we're gonna think about dynamic programming. If it is not possible to use dynamic programming, maybe it is a greedy. Yeah. Let's just check that if we can solve it by using the greedy. So for example, we have 165 4, yeah, for the first example, and 62. So but the greedy idea is that we're gonna choose the numbers as much as we can. So instead of choosing 1, we're gonna choose 16. Yeah, because only in this way we can get the minimum number of substrings. So if we choose 165, it's gonna be definitely more than 4. So the greedy idea is that we're going to try to choose as many numbers as we like. So instead of choosing 1 or 6, we're going to choose 1, 6 together. Yeah. And then we're going to choose 5 and 4, and then 6, because we cannot choose 62 because it is more than k. And then we're going to choose 2. So how many splittings? There are 4 splittings. Yeah. Another way is that we can prove that. How can we prove that? Maybe this is not the greedy idea, so we can prove that. Maybe we just want to choose one number, 1. Okay, we just choose 1. And for the next number, 65, we cannot choose 65, we have to choose a 6. And for the next number, maybe we're gonna, choose 54. Yeah, and for the next number, maybe we want to choose 5, maybe. And for the next number, we may choose 46, and the last one gonna be 4. So how many splittings? 1, 2, 3, 4, 5. There are going to be 5 splittings. Yeah, so 2, 46, 5, 6, 1. Yeah, definitely the greedy idea is that we're going to choose the numbers as much as we like. Yeah. So instead of choosing like that, we're going to choose 16, 54, and 6 and 2. So how many splittings? 1, 2. How many parts? 1, 2, 3, 4. There are going to be 4 parts. So that's going to be the answer. But how can we check all those numbers? It's going to be easy. We can use the list groups to solve it. So in order to avoid making mistakes, we have to use some basic patterns to solve it. So we're going to use I and N. So I going to be starting from 0, as we are using listing groups. So we just list them together to check if that is possible. So for I less than N, here we're going to use a start equal to I, and j equal to start, and then we're gonna check the j while j less than N. And here, before that, let's start to prepare a substring. So from the beginning, the substring is gonna be an empty string, and then we're gonna use the integer to check. If the integer of the substring plus sj, yeah, if it is less than and equal to k according to the description, if it is less than and equal to this k 16. So what are we gonna do? We're gonna update the pointer j. Yeah. But before we updating it, what gonna be the substring? Yeah. So the substring gonna be we need to update the substring as well. From the beginning, the substring is empty, and now the substring gonna gonna become substrate plus this j. So from the beginning it is empty, then it is 1, and then it is 16. So 16 is also okay, but after 165 it is not okay. So we're gonna go out of the while loop. Yeah, but even we go out of the while loop, we didn't plus this 5. It is only 16. So this is why I'm gonna write it like this. Now, if my calculation is safe, I gonna update the final result. So the result is just counter how many parts. Yeah. So after that, I'm gonna update the pointer I gonna equal to j. But here is one problem. So what if I equal to j? This means there's no updating. This means something like here, this 8 is not valid. So if it is not valid, this pointer I is not updated to the next one. Yeah. So if this happens, this means it is not possible. So we're gonna return a negative one. Otherwise, we're gonna go out of the while loop and return the result. Now let me just run it to check if it works. As you can see, it works, and we didn't make any mistakes because this is the list groups pattern. If you know something about why we can use a two while loop and the list group pattern, basically we can solve it easily. We don't need to think too much more about it, and we don't need to make so many mistakes. And the time complexity is O(n), because even though we have two while loop, actually this I always goes forward and this j always goes forward, as there's no going back. And yeah, and the I gonna equal to j, so the time complexity gonna be O(n), n gonna be length of the string 10 to the power 5. I think that's all about it, but before that, let me just submit it to prove that it can pass. As you can see, it passed for all testing cases, and it's pretty fast. Thanks for watching, see you next time.